Hey, let me check my speaker. Hello, hello. Hi, Isaac. Can you hear me okay?
Yes, I can.
How are you?
I'm doing good. How about you?
Okay. Got some questions for me?
Uh, I kind of wanted to like run down on the concept of circuits one more time.
Okay. So when you say run down on the concept, can you be more specific? Was there a particular problem from homework maybe that you needed help on? Or is there a particular procedure that you need help on? Like maybe the procedure where you have to give the circuit if you're given the Boolean expression, or maybe the procedure where
The
you
Boolean expression is when you full and half adders, right?
know the Boolean expression would be the expression with P's, Q's, R's, ands, ors, nots.
Oh, okay. So like the basic structure of it.
It's called a Boolean expression. It's the expression that determines when the particular circuit should output a one. It tells when you want a one. So,
Yeah, yeah. That's the one I was talking about.
okay, so did you get your homework back?
Uh,
Did you look at your homework?
was that from
It's homework number
was that
two.
sent through was that sent through Outlook?
Homework two?
You're talking about homework too. Then I got
Yeah,
homework too back. My bad.
yeah, in class, you got that back, right?
Yep, yep.
Yeah, do you have that in front of you?
Yeah.
I'm gonna, are you in section 003?
Yeah.
Are you in the Monday, Wednesday section?
Yeah, I'm in the Wednesday, 2 p.m.
Okay, so I can look, and see how you did on that, just to see what's going on with that. Yeah, homework two, you could have done better on that. That was the one when we drew circuits. So do you want to work through, did you know that there's an office hour where we work most of the problems in
Oh
homework
yeah.
two?
Yeah, you did it with the person that's just right next to me. I saw the whole thing.
That's
I
good.
even I think jotted down the question at the end with the full and half adders.
Okay. So what do you want to work on? Circuits or full and half adders?
Actually, to be honest, I think I can figure those out. Uh,
Okay.
I um, I think I need more uh dang.
So I'm still grading homework four. I've been emailing people their homework four as I have graded it. Yours
Mhm.
is right here near the top of my stack. Mania, you got your homework four back, and Eli, you got your homework four back. Um, Tell you what, Isaac, let's see if one of these guys has a question that's kind of more clear, and I can come back to you while you just get yourself organized.
Okay.
So I don't know which one of you guys came in first, but who has a question?
I had a question on homework four, but I didn't realize that you sent mine back. So I'm just gonna let Manaya go, and I'm gonna check my homework four, and I'll come back.
Okay, Mania, what you got for me?
Honestly, I just came in to see if anybody had questions on the homework, and then I could follow through basically. As of right now, I have no questions. I just wanted to see if you were working on anything.
Okay, so it's back to you, Isaac. Do you have a particular question, or do you want me to make up a kind of work on?
Yeah, to be honest, just you make up a question that you think will be best for us to like learn.
Okay, can you tell me, do you mean on circuits? Or on adders, or on Tarski, or on logical equivalence, or,
I think Tarski would be the best.
well, why don't we look at some of these Tarski questions then that were on the homework? So this is the Tarski Worksheet 3, and I asked everybody just to use the form that was in the day 7 notes, where B, D, and G are the gray objects. Okay. So let's just go ahead and get started. Shall we just work through some of these?
Yep.
All right, so the first Tarski Worksheet 3, see day 7 notes. So the first question, A, says, okay, the original question is, there exists an X and there exists a Y such that circle X and triangle Y and below XY. Let's just make sure we all understand what that even means, okay? Is it in good focus? All right.
Yep.
So it means that there is some object X and that there is some object Y, and the predicate is, the property is, X has to be a circle and Y has to be a triangle, and below XY. So the first thing we need to understand is what below XY means. We discussed this, of course, the day before we even really dug into Tarski. This means X is below Y. It doesn't have to be in the same column, like C is below B, but C is also below A. D is below A and B and C. D is not below D, D is not below E, and of course D is not below any of the ones that are in rows lower than the row that D sits in. So when we say X is below Y, they don't have to be directly below in the same column. It just means X is in a row that is below the row in which Y sits. Does that make sense?
Yeah, that makes sense.
And that's the interpretation. So when we get ready to try to figure out if that's true, we're looking for an object that's a circle. We'll call it X. And an object that's a triangle. We'll call that triangle Y. And we want to make sure that circle X is below triangle Y. Are we going to be able to find an X and a Y that make this true?
Yes.
So what would be an X and a Y that would make this existence statement true? What would work for X? What would work for Y? We pick one of these named objects for X, and we pick one of these named objects for Y.
Okay. Okay. C would work for uh for X,
Good.
and for Y, E would work.
All right, E is definitely a triangle, but let's check. Is X below Y? You picked C for X and E for Y. Is C below Y?
Oh no.
C below E? Nope. So try again.
Yeah, I can't find a triangle that's below.
No. The circle is X.
Oh,
X is below. See, the X comes out front. Circle X is below triangle Y is what we want.
Okay. So circle H is below E.
There you
Triangle.
go. Circle X equals H will work if you use Y equal E. By the way, A is a triangle as well, so we could let Y equal A and X equals C would work, and so would X equal H, and so would X equal J. Triangle E doesn't work with circle C, but triangle E would work if we picked X equal H or X equal J. So there are lots of right answers. You just pick an X and a Y that exist to make it true. Let's go ahead now and write the negation. Okay. So when we bring a not through this whole statement, what does it do to the there exists and the there exists?
It flips it to for all.
So it's for all X and for all Y. And then we have a not that we're going to have to bring across this and operated predicate. We'll do that in the next step. So we'll finish it now. For all X and for all Y, bringing this not through using De Morgan's laws, what happens?
You negate circle,
So
triangle, and below, and you flip the ends to or.
correct. So not circle X or not triangle Y. Or do you know how to negate below XY?
Would you say you would say just not below? I don't
That's
know.
correct. We don't want to think that it's above because the negation of below is not above. We just say not below. So we interpret this to mean for every object X and for every object Y, X is not a circle or Y is not a triangle or X is not below Y. But we've already figured out that the original is true. So the original is true because you've already found an X and a Y that work. So how do we get full credit? We say, hey, let X equal, which one did you want to use for X and which one did you want to use for Y?
We can just use C and A, to be
Okay,
honest.
let
Let X
X equal
be.
C, good, and Y equal A, that's the first step. So we've picked the X and the Y that exist. So this part's done. Now we need to verify this predicate. We have to talk about each part of this compound predicate. It's an and operated statement, so all components need to be verified. So circle C and triangle A are true. You can just say it. By telling me what shape they are, you're telling me you know that C is the circle and A is the triangle. Also, C is below A. And that's it. Full credit.
Okay, this makes sense.
Good. Shall we do another one?
Yeah, why not?
All right. So let's do, how about we do C? We'll skip B because I'm grading B. I'm boxing B, so people will get that feedback back. Let's do C. C says for all X and for all Y, circle X and triangle Y together imply not same color, XY. That means they're different colors. And this whole thing is a big predicate after this quantifier. All right, let's just go ahead and write the negation. Shall we?
There exists X, there exists Y.
Good, there exists an X and there exists a Y. And then we'll take an extra step to work through the negation of this if-then, because if-thens can be a little bit tricky when we're trying to negate them. All right, so now we just bring the there exists an X and there exists a Y down. When we bring this negation across this if-then, it's helpful if we realize this is an if P, then Q, right? So it's helpful
Yeah.
to review, how do we negate an if P, then Q? How do we bring a not through an if P, then Q? Do you remember?
You negate both?
Nope. This is something you need to learn because you need to know this for the test. We've talked about this many
Oh, it's
times.
P, then not Q, right?
There's no then, there's no arrow. Because listen, we learned when we learned about quantified statements that if-then statements are universally quantified. But we know when we negate a universally quantified statement, we get an existential statement. And if-then statements aren't existential. So the negation of an if-then cannot be another if-then because they would.
Oh,
So it's P,
P and negation Q.
thank you, P and not Q. P
Yeah, this
happened
just flew out my head.
and Q didn't follow. Maybe that's what you meant to say. Okay.
Yeah, that's what I meant to say, my
All
bad.
right, so tell me what to write now.
You would do circle X and triangle Y.
Good.
Uh, oh, another end.
Yep. And
No, it will be a positive same color since it's negated.
that's right. Not same color is same color. X, Y. So this statement might be a little easier to suss out because it's an existent statement, and they're always a little easier to suss out than for all. If this
Yeah,
negations will always have the opposite truth value of the original, of course, right?
yeah.
So the negation says there is an object X and there is an object Y. X is a circle and Y is a triangle, and X and Y are the same color. So do such objects exist?
Uh, yeah.
What would they be?
Probably like H and A, C and A.
That's right. That's right. A is the white triangle and all the circles are white, so you can pick any one of those. So that means the negation is true, so the original is false because the negation is true. And now we'll go ahead and justify why the negation is true. But on the test, I'm going to ask you to give the truth value of the original. I'm missing a whole bunch of stuff here. I need to say the original is false because the negation is true. Okay, Eli, I see your chat. And now we go ahead and we verify that the negation is true if we let X has to be the circle, so C or H or J, which one do you want to use? It doesn't matter.
We can use J.
If we let X equal J, and y equal a. Notice J is a circle, A is a triangle, and they are both white. And I know some people used gray A, but if you told me that it was gray, I just let that slide because it might have kind of looked gray if you didn't go back and pick up this particular worksheet. But it was intended to be white.
Okay, this makes sense, but what's it called? So when we're doing these types of questions for the justification, all we have to say is if the original or the statement that's negated is true, then we
No,
try to just prove it
you're going to tell
or
me,
false.
you're going to tell the directions are going to be like the directions on worksheet 1.
Okay.
The directions on worksheet 1 were to write the negation and then determine the truth value of the original. But that's okay because you can look at the negation to help you figure out the truth value of the original. But the first thing you need to write is the truth value of the original. The original is false. But if you need to say because the negation is true, because you want to actually show why the negation is true in your justification, that is fine.
Okay.
You
That
just need
makes
to
sense.
connect it to the fact that that makes the original false if the negation is true.
Okay. Thank you so much.
You're welcome. Eli, what's your question?
Yeah, so I was looking at some of the comments you made, and I think it makes more sense now, what I was doing wrong. And let's see here, what my question? It says, yes, my question is when it says for all x and for all y, can x and can x and y be the same object if in the question it doesn't specify that x cannot equal y?
That's right. In fact, you have to check it for when x equals y as well.
Okay. So for instance, if it is talking about, for all x,
Well, what
um,
problem? You want to just tell me which part you're looking at so that we can just talk about it?
let's see here. Well, it's not a specific problem. It's kind of like a mix because I was looking at G and H, and G is talking about, being below X, Y, and then H it has that whole thing of well, both of them there, X cannot equal Y for both of the problems, but for G is talking about, it being below or above.
Well,
So if it
actually,
does,
there's a hypothesis here that x is not equal to y. You see,
yeah,
this is an if-then. And so let's look at G. G says there exists an object x such that for every object y, and here's the caveat, if x is not equal to y, then below xy. So this isn't quite the same as having a compound predicate that's like a big and statement. This is an if-then statement. It's not like a big and statement.
yeah,
And it says we need to find an x that will work for all y if we're looking at a y that is not the same object as the x that we chose, then below xy needs to hold. We're looking for an object x that's going to be below y. The x will be below y for all of the y's that are different from x. See, we wouldn't be able to do this if this caveat wasn't here, if this condition was not present as hypothesis, if it just said there exists an x such that for all y below xy, that would be false because we would not be able to find an object x that is below all y, period, because y would have to also be x at some point when we're checking all the y's. And there is no object x that is below itself. But when this is the condition, we're only checking that x is below y in the instance that this condition holds. In other words, we're looking at a y that's different from object x. That's when we need x to be below y. Does that make sense?
Yeah, no, that makes a lot of sense because like I'm looking at the grid and to answer this question, the what's it called? The hypothesis is true. So the original is true, and that's because let x equal j. J is below every single object y, and j is not equal to y. I don't know if I said that right.
Yeah, j is not y. Because, yeah, the original is true. Because we can pick that there is an object that's below everything else in this diagram, namely circle j. That can be our x. You know, there does
Hmm.
exist an x, that as long as y is not equal to x, x will be below y for all of the y's as long as they're not equal to x.
So what's the best way of saying that? Because
Well,
I
there,
want to do better with explaining that.
well, the thing is, it's an existence statement first.
Hmm.
So we want to state the x that exists. So let x equal j. Now we want to talk about why this choice of x will be below y for any y that isn't itself. All right, so we need to look at all y that satisfy the hypothesis. You see, we don't care if the hypothesis is false. Like if we're looking at a y that is equal to x, then this is false hypothesis, and the if then is true by false hypothesis. Just like when we're looking to see if an argument is valid, we only are interested in the rows of interest where all the premises were true because the premises constitute the compound hypothesis. We don't care what happens in the rows that are not rows of interest because those are rows where the hypothesis of the argument failed because one or more of the premises were false. Well, if this is false because we're looking at a y that equals x, then we don't care about what happens here because the if then is true by false hypothesis if we're looking at a y that equals x. But we need to look at all y that satisfy x not equal to y. For those y's, for all of those objects y, clearly circle j is below y because it's all by itself in the bottom row. Because j is alone in the bottom row. Does that make sense?
No, that makes sense. I was also thinking, with saying, let's see here, let x equal j, for every other object that is not j, j is below those objects.
That's good.
Okay.
That would be fine. Yeah, there's lots of correct ways to do it. Once you indicate that you understand what the statement is actually saying, then there are lots of correct ways to justify, your response. It's really about figuring out what the statement is saying, isn't it?
Yes. And then also, I don't know if anybody else wants to keep doing these like Tarski's world because I also had another question with the what do you call it? The circuits, but I don't want to move on
So
unless
it's
anybody.
all right. Yeah, because we're at 8:30. Does anybody want to see any more Tarskis? Because if there's one more that you're burning to know, we can do it, or we can move on and come back to more Tarskis later.
No, we're good.
All right, circuits. Let's move on to circuits. What would you like to know about circuits? Remember that there's sort of three things that go together. There's circuits. Every circuit has a Boolean expression. that describes when the circuit is going to give hot output. And every circuit has an I/O table, which is just sort of like a shorthand quick look at when the output is hot or cold. And we can, is it just me or is there just a mean old glare on this page? I'm gonna have to get like a scarf and drape it over my lamp or something. Start a fire. Old Dr. Jude's gonna start a fire. Let's see how hot this. No, it's a cool bulb. Let me see if this helps. Trying to do my production here. That helps, doesn't it? Okay. All right, so what would you like to do? What are you comfortable with? And what are you not comfortable with? Like, what things do you understand and what parts seem mysterious? Let's see if we can address those questions.
Well, I just want to practice uh first adding the digits and then creating a circuit based off what we added together.
Oh, you want to do an addition problem? Sure. Adding binary numbers. So let's do one of those where we have half adders and full adders, and we have carry digits and sum digits, right? And they're just three basic rules to remember. So the rules to remember, shall we just go over those real quick? Because honestly, if you understand the rules to remember, it can really help you. Digits are added only if they are in the same column. It's the same with any kind of addition problem that we do. We only add digits that are in the same column. Like if we were adding 529 plus 18, we wouldn't add the 5 to the 2 to the 9, would we? It's not the way adding works. We add the 9 to the 8. Get a 7, that's the sum digit, and a carry, which goes one digit to the left. The carry digit, well, maybe I'll say the sum digit. The sum digit stays in the column with the digits that generated it. So the 7 from 17, that's the sum digit. It's the ones digit. It stays in the ones column with the digits 9 and 8 whose sum generated it. Stays in the column with the digits whose sum generated it. And then the carry digit belongs one column to the left of the column containing the digits whose sum generated it. So when we added 9 plus 8, it's 17, it's 7 ones, and the 1 is 10, right? It's 10 ones. The 1 goes in the tens column, one digit to the left of the column containing the digits 9 and 8 whose sum generated that carry. Does that make sense?
Yes.
So if we want to add P, Q, R, I'm going to put some space between these so we have room to work. S, T, U, actually I should use S. W, T, U plus V plus X. Let's say we want to add that. Okay. So you always want to space it out so you have room. So even if I give you the problem, you're going to space it out. All right, so we start in the ones column. Okay. Start adding in the rightmost column. We always start adding in the ones column. So I guess it's 4 things. All right, so we're going to start adding, and we can add 2 or 3 digits. If there are 3 to be added, go ahead and add 3 digits. So what would you add first?
I would add RUV to make S1.
All right, so I'm just going to make some notes. We're going to add RUV. So we're going to draw it down here at the same time. Here comes R and U and V, and they're going to get added with a full adder, correct? It's a full adder because it's 3 digits being added. So S1 is going to be an output, and carry 1 is going to be an output. We always have 2 outputs. Okay? So S1 stays in the column where it was generated. Carry 1 needs to go 1 column to the left. It can go above the Q, it can go below the T. I'm just sticking it between the Q and the T. As long as it's in this column, it's fine. Anywhere in there's good. Now what?
I would add S1 and X to make S2.
Yeah, S1 and X are in the same column, and they're the last digits in the ones column. There are only 2 of them. So we'll use a half adder and add those, and it'll give us an S2, and that S2 stays in the column in which it was generated, right? It stays right here. And it's it. There's nothing else to add to it. So it becomes a final output digit. I like to put a circle around it just so I know, yeah, it's a final output digit. And then there's a carry 2 that's coming out. We always want to draw in the circuit the sums and carry digits, but we also want to always put them here. Where does the carry 2 go?
It goes where are you asking for the circuit or for the adding?
Well, it's sitting here in the circuit. For now,
Mm.
I'd like to know where it goes here in this diagram so I know what I'm going to be adding it to eventually.
Oh, it's going to go is
We
it
could,
above Q?
yeah, we could put it above Q if you can fit it, or you can put it below Q if it doesn't fit. You could put it below T. Doesn't
Mm.
matter. As long as they're in this column, we're going to get to them eventually.
Okay.
But I'm like you. I've got all these notes up here. I would prefer to have room up there and put the carry 1 and carry 2 above Q, but they don't have to be above, but they could. But the point is, hey, we're done with the ones column, and now we see we're ready to move over to the twos column, and we've got Q, C1, C2, and T. That's 4 digits. We can only add 3 at a time. So we might as well just go ahead and take the first 3, right? Carry 1 and carry 2 and Q, right? Pull the Q over here, and we can add those with a full adder because they're 3 digits. Is this making sense?
Yeah, it's making sense.
And we have a sum 2 and a carry 2. Excuse me, sum 3, right? Because we already used sum 2 and a carry 3. So where did the sum 3 and the carry 3 go?
The sum three is going to go. I know there's no space, but usually I would put it in between Q and T.
Yep, but it's pretty full.
Yeah.
So
So yeah, put on the bottom.
we can put some 3 here,
And then we can put carry 3 above P.
carry 3 up here. Yeah, I like to put it above too. All right. All right. So now we're not quite done in the twos column, are we? Because we have T still and we have some 3, whichever order they're in.
So S3 and T are gonna make S4, and that's gonna be the final output for that row.
And what kind of machine do they go in? What kind of
It's
circuit?
gonna be a half adder.
So there's a half adder, and we are sure going to get S4, and that will be the final output in that column, because we have just added these. And and of course there's a carry 4. Where does it belong in our picture?
Oh, that's gonna go. You can put it, I guess, below P.
Yeah, it'll be okay. Trust me. I know you're like me. You like it all neat. And normally you wouldn't have all this crap above it and you'd have
Yeah.
right. But it doesn't matter. As long as they're in that column, we're going to get to them. We're not going to forget because once like we're getting ready to move over and we'll start at the top. We're not going to miss any of these. Okay.
Hmm.
So carry 3 is here. And carry 4 is here. It's double dog leg. What does it get added to?
Sorry, can you repeat that one more time?
Well, we've got the carry 3
Hmm.
wire and the carry 4 wire. We're waiting to do something with them. What should we do with the carry 3 and the carry 4?
Oh, we should add it to P to make, yeah, add it to P. And that'll make S5.
It will.
Since you carry 3, let's carry 4.
And there's a carry 5. So where does S5 go?
S5 is gonna go below W.
Yeah. Yeah, S5 belongs in the same column that generated it. And where does the carry 5 go?
Carry 5 is gonna go a column to the left.
Okay. So now we're going to add W with S5 in a half adder. And that's going to give us S6 and carry 6. I've made these too long. And S6 is down here, isn't it? Because we just finished up the 4s column. Where does carry 6 belong?
Carry 6 is here. Is it gonna go below C5?
Sure, below, above, yeah. And so now that's it to do is run carry 6 and carry 5 through a skinny old half adder. And we get sum 7 and carry 7, barely enough room. And these are final output digits. Which goes where?
Um, let's see here.
Sum
S5.
7 and carry 7.
Oh, so S7 is going to go at the bottom. That's the final output. And then carry 7 is going to go to a column to the left of C6. And we can bring it down.
Exactly. I apologize for this. I should back these up and make these shorter.
Yeah, I'm also in the corner of my page. I'm trying to like fit it in there.
I'm gonna make this shorter. I'm gonna clean this up. That is too small. I don't like it.
Are we gonna do a lot of these on the test?
Hundreds. No, no, don't worry. Don't worry. In fact, I'm going to bend the P wire up close to these because they're already there and put these through a full. And then we get some 5, which goes into a half adder with W. Carry 5. Sum 6 is final output. Then carry 6 goes up into a half adder with carry 5. Finally, this is easier to read. Sum 7 and carry 7. Yeah, that's a lot easier to read. I would be more concerned with Boolean expressions and IO tables and circuits than I would be with this. This is sort of gravy. There is going to be an extra credit problem on the test. But it looks like you've got this down, Eli. Not sure what you're worried about. Looks like you've got this down.
Thank you, Professor. Yeah, I definitely understand. I just wanted to practice, but thank you for the help.
Yeah, and there was an office hour where I threw out a couple of practice problems at the end of the office hour last week. You can just make one up, you know? You can, you know what I mean? Like you can just make one up. You can just say, do later. And you can just make it up yourself and see what you can do with it, like P, Q, R, T, U, V, W, Z, X, Y. You know what I mean? And just like
Yeah,
see what you can do with it. And then if you want to show it to me, you can email it to me. It doesn't even have to
Oh,
be a PDF. You can just take a picture of it and I'll take a look at it. You can take a look at it tonight or in the morning. All right. So other circuit issues. Does everybody understand the beauty of disjunctive normal form and why it's so helpful? Because it gives us a direct line to the IO table. Disjunctive normal formal. And that's what Towson should have for math majors and computer IT majors. We should do a disjunctive normal formal. That would be crazy. Right. People are like, no. Listen, like if we know that P and not Q and R, or P and not Q and not R, or not P and Q and R, we know that that's the disjunctive normal form for a circuit. It's the Boolean expression. Find the IO table. You can do it directly from the disjunctive normal form. Does everybody understand this? Just say yes. If you already understand this, I won't waste time.
yes, I understand it.
Anybody else?
I'm kind of iffy about it.
All right. So Eli, you understand it?
Yes, I do.
You want to explain to the other guys how it is that we know? First of all, can you explain to them why I know I have 3 input variables, P, Q, and R?
Those represent what's hot. That what's true in the IO table.
Well, they'll also be cold sometimes. But the point is, when I scan the Boolean expression, all I see are P's and Q's and R's. That's what I mean. I know that I'm going to need a P, I'm going to need a Q, I'm going to need an R
Oh,
because I
okay.
see those variables. Uh, and we're going to have an output variable S. So we always have our output column and we have our input columns. And we know that the inputs are going to be whatever we see in the Boolean expression. Okay, guys? How many rows is this particular table going to need?
4.
8 rows.
Explain why it's 8 and not 4, Eli.
Because there's 3 variables. The first one is gonna have 4 truths. Well, I know it's by factor of 2. So like you take how many letters you have. So P, Q, R, that's 3. So
You would
then you
have
do
n equal 3 variables. So it's 2 to the n, which is 2 cubed, which is 8 rows.
hmm
It's always the power of 2. The power is the number of variables. So if we only had a P and a Q, yeah, it would be 4 rows because 2 raised to the 2 would be 4. But we have 8 input variables. So under P, we put 1, 1, 1, 1. Do not start with O's, people. ChatGPT starts you off with O's. That is wrong. That is not disjunctive. That is not normal form. So like in truth tables, we would have 4 truths followed by 4 falses. Ones are
Oh,
three.
okay. That makes sense.
And then under, right, true is 1, false is O. False means cold wire. 1 means a hot wire. Juice is flowing. So there's our canonical setup. All right, that's our input columns. Now, Eli, do you want to explain how you would analyze this to figure out which rows the output would have a 1 in, hot output?
what I do know is that the Boolean expression at the top, those 3 represent what's going to be hot, and everything else will be cold.
That's right. So P and not Q and R. This is actually saying P is hot and not Q is hot and R is hot. But what does it mean if not Q is hot? What does that tell us about Q?
It's a 1.
Not Q is on. So what does that tell us about Q?
That is not hot.
Yeah. When you see not Q, that means not Q is hot. That means Q is cold because not Q and Q have opposite states. So which row of this 8-row truth table represents the input state where P is hot and Q is cold and R is hot? Because that's what that means.
3.
In row 3, P is hot and Q is cold and R is hot. Let's just, yep, this is P and not Q and R. That's the way. This is a full description of this input state. You see, there are 8 different states of possible inputs to the circuit. The states consist of the 3 input wires and whether they're hot or cold, each one of them. So in row 3, P is hot and not Q is hot, but that makes Q cold and R is hot. So that means we want a hot output if this happens, or this is what's happening, or this is the input state. You see, it tells us the 3 different input states that should yield hot output. And that tells us that we want a 1 as the output. S is 1 for that row. Okay, so what row is the correct row for this second input state?
It's row 4.
Row 4, why is it row 4?
because P represents hot, and then because it's not Q and not R, then they're both gonna be O's.
Yeah, since not Q is we write what's true. Okay, we write what is hot. P is hot and not Q is hot and not R is hot. But that means P is hot and Q, which is opposite of not Q, is cold and R is cold. So when I read this, I think to myself, P is hot and Q is not hot and R is not hot. That's what's happening in row 4. P is hot and Q is not hot and R is not hot. This is a description of that input state. And under those circumstances, we want a hot output because, again, the Boolean expression tells us exactly when we want hot output. We want hot output if this happens, or if this happens, or if we see this come in as input. All right, somebody besides Eli, what is the correct row for the input state that is expressed in this third component of this disjunctive normal form?
Is that 5?
It sure is, because P is cold, P is O, Q is hot, Q is 1, and R is hot. So this is described by not P and Q and R, and we want a 1 there. And then we want O's everywhere else because the Boolean expression is a complete description of when we want hot output. Okay, so it's really easy to go directly from Boolean expression to IO table if that Boolean expression is in disjunctive normal form, because inside the parentheses is a complete description of one of the 8 input states. Each one of these components gives a complete description of the 3 input wires. So when you see 3 of these, you know you're going to have 3 ones. It's just a matter of carefully figuring out which rows those ones go in. I do recommend that you check out an earlier office hour from last week because we did work homework 3, or was it 2? Which one was the circuits? 3. Yeah, we worked a bunch of the problems from homework 3 in that other office hour. So it's already up and the notes are up. You can just peruse the office hour notes and you can see the answers to a lot of the questions on homework 3 if you have trouble now drawing the circuit. Like we did 3 of them. And we also did some in class too. You can check the lecture videos from the online class, okay? The live lecture videos on my YouTube channel. There's all kinds of good stuff. Yeah, the videos of the office hours are on my YouTube channel too. Does everybody know where the YouTube channel is? Is there anybody in here who hasn't checked it
Just
out?
your name.
Let me show it to you. Look, my YouTube channel. Listen, the address is all over the place. Like, if you go into, like, here it is. It's at, here, I'll put it in the chat.
If you just search your name, it shows up.
Liz Good, yeah, Liz Good. Yeah, and look, there's office hours. Like, there's a bunch of them. You want to, I'm so sorry. There's a bunch of them. Like this is the one where we did a bunch of circuit stuff. And we were able to identify. See? Yeah. And that's the OR operating system. And we did arguments. Columns. All right, and then here we did. Am I sharing my screen with you? On our office hour.
Okay, so for Tarski's World worksheet number 3, I had the question for E. I'm having the issue.
So we work through stuff. Yeah. In the office hours. Like circuits. It's all there and it's all in the notes. About what P and and if you need older stuff, there's older stuff. Tarski stuff like crazy. Like multiplying a -1 times a -1. The negatives cancel. And even older stuff where I don't know, we were looking at. That's the nature of statement forms, practicing, negating. Okay. So the easy way to always get it right is to say there is a fish. All right.
I had a question.
Okay.
Is this the end of this question?
Is this the end of this question?
Yeah, that
There would
question
be a
right
part
there.
B.
Okay.
There would be a part B. Draw the circuit associated with the given Boolean expression and IO table. And that's why I'm pointing you to the office hour from September 25th, because we did a bunch of drawing circuits from Boolean expressions in that office hour. Does that answer your question?
Yes, ma'am. Thank you.
I'm glad that you've discovered all the videos.
Yeah, I've been watching.
Good. They're helpful because, we soak up a lot in class, right? We talk about a lot of stuff. It's nice to be able to go back and kind of hear it again, isn't it?
Yep, you can slow it down and everything too.
Yeah. You can slow it down. Manaya, have you gotten your questions answered? I know you were just here hanging out.
I mean, I had no questions and just hanging out. So yeah.
It's nice to
Oh
see.
wait, I guess I have a question. Is there like do you have like a test like review? I know about all the worksheets, but do you have like a I don't know, like a test review?
The
Like
best test review is for you to make it yourself by going through all the homework and the notes. Go through all the notes. You see, this is not high school.
okay.
This is college. No, seriously, I don't want to deprive you of the benefit of you actually thumbing through all of your notes and going through. Start with class notes and special homework problems. If there were special homework problems that you did not get full credit on, then make sure that you can work those. Search out the information in the lecture videos or on WebAssign or in the office hour videos and work the problems on special homework that you didn't do well on. And then go back to WebAssign. Even though you can't change answers at this point, there are definitely problems that you'll see on the test that will be like WebAssign problems. And I guess who's talking? Manaya?
Yeah, that's me.
Yeah, Manaya, which day are you, which class are you in?
Monday, Thursdays. Sorry. No, Monday and Wednesdays at 2 p.m.
Monday, Wednesdays at 2. Did you look at the office hours for our class from,
Office hours on Wednesday.
excuse me, the class notes? Like, were
Yeah.
you did you miss class or were you late to class? I'm not
Well,
trying to put you on the spot. I'm asking
yeah.
you, were you
No,
late?
well, last week I was out due to COVID, and then this week I was here all week.
Well, last week, what do you mean this week? You
Oh,
mean,
sorry. I was here. Sorry, yeah, I forgot this is a new week. Last week I was here all week, and then the week after, I mean the week before that, I was out.
are you aware of where the class notes reside on the Blackboard webpage?
Yeah.
Well, then you're asking for something that's already been given to you. Look, were you in
Yeah,
class? Were
you're
you
talking
in
about when we
class? Were you in class on Wednesday?
yeah.
Yeah, well, what did we do for the first 20 minutes of class?
We went over like what we should learn and all that.
this is basically the review sheet with pointers to documents that you should check out, like the if P then Q document. See there? We did. This is the stuff you need to know. So I'm not really sure what you're asking for more than what I've provided. You've got all these special homeworks. Unless you made hundreds on those, you should go back and work those problems. Did you go to the good stuff folder?
Yeah.
Did you work the worksheets for extra practice?
Yeah, I'm looking at those right now.
Yeah. Well, that's a good thing to do.
Okay, yeah. I just wanted to ask.
Ask what?
Well, my question's already asked. If, there's like
What was the question actually? Can you
there's like a worksheet for like the final assignment or kind of like a review. But all right, but you already answered my question. So it's like,
Yeah, we've got a list of topics and you've got lots of worksheets and I think what you want is a practice test.
yeah, pretty much.
Yeah, no, that ain't happening.
Okay.
Nope, nope, but you've got lots of good stuff to practice on with solutions available. And I do recommend those office hours, especially on September 25th, if you have any issues whatsoever with circuit design, okay?
Okay. That's pretty much all I have. See you tomorrow.
See you tomorrow. Isaac, did you get all your questions answered?
Yeah, thanks, man.
You're so welcome. I'll see you tomorrow.
See ya.
Bye.